Okay, so this video is going to talk about the rules of exponents. We're going to go through half of them, or a little bit more than half of them here, and then in the next section we'll go over the other portion of the rules of exponents. But before we start that, I want to talk about what an exponent is. And an exponent is something like when we do 2 to the 4th power. And when you're looking at something like this, it's important to remember what the pieces mean. So this piece right here, we call this the base. This is the number that we're actually multiplying. And then we've got this piece up here, which is what we call our exponent, and that tells us how many times we are multiplying that number. So in this case, we're doing 2 to the 4th power, so we're multiplying 2 times itself 4 times. So this would be 2 times 2 times 2 times 2. So 4 2's. There's several different ways you can multiply this together, so whatever's the most comfortable for you. I tend to, especially with ones like this where I have an even number, I multiply this set and this set, so this would give me 4 times 4, and 4 times 4 gives me 16. Okay, and I want you to be very careful when you're multiplying and we have negatives. So let's say that I want to do negative 3 squared. Okay, so when I do negative 3 squared, remember you're doing negative 3 times a negative 3. And if you'll remember all of the stuff about our multiplication, if we do a negative times a negative, that's a positive. So this would end up being a positive 9. And that is vastly different than saying negative 3 squared. I know it doesn't seem like it should be different because it looks like it's the same thing, but parentheses make a lot of difference when we're talking about multiplying. And what this is asking you to do is negative 1 times 3 squared. Well, we already know that 3 squared is 9. We just figured that out on the last one. So this is really saying negative 1 times 9, which would give us negative 9. So just be real careful with your negatives. If you have a question about that, just email your instructor and they'll be able to help you. So now for our rules that we're going to go over, our first rule is exponent of 1. And it's a really pretty simple rule. What all that is saying is that if you have a term a and it doesn't have an exponent written, it is always a to the first power. Okay, and that comes into handy when we look at our other rules, but it's the basic idea that if I have x, it's the same thing as x to the first. Or if I have 5, it's the same thing as 5 to the first power. And it's kind of like when you have x and people go, well, what's the coefficient? It's 1. It's the same thing here. If I don't have a number written down as my exponent, my coefficient, or my exponent, excuse me, is 1. The next rule is an exponent of 0. This is actually one of my favorite rules because it's just really, really simple, although we tend to kind of mess it up a little bit. And this says that if you have a variable or a number that's raised to the 0 power, the answer is always 1. So again, any variable or number raised to the 0 power is always 1. So if we have something like 3 to the 0, that's 1. We can have things more complex, like if we had 2x squared raised to the 0, that is also 1. So that little 0 right there causes everything to turn into that 1. Okay, so now our next rule is the product rule for exponent, and that basically says that if you have two terms that you're multiplying together and they have the same base, so these both have a base of a, what we're going to do is take their exponents and add them together. And most of you guys probably already know this rule. Maybe we don't have it formally written out, but we've done it in the past when we've done multiplication. So what this is basically saying is if you have x squared times x to the 5th, this is the same thing as x to the 7th. And again, all we're doing is taking this 2 and this 5 and adding them together. Okay, so our quotient rule is very similar to our product rule, except for we're doing quotient. So quotient, remember, is our division. So we have a to the n over a to the m. Again, we need to have the same basis, so both in this case a's. And this is going to end up being a to the n minus m. And one of the big things I want to point out for you is that notice when you do the subtraction, your exponent from your top term goes first, followed by the subtraction of your second term, which goes next. And you're going to have to really pay attention to your to your signs on this because it's an easy thing to mess up. So for example, if we have 5 to the 7th power over 5 to the 5th power, we can say, okay, I'm dividing these guys, so I'm going to subtract the exponents. Now notice when I did this, my a or my base didn't change, and that's the same thing that's going to happen here. I'm going to keep my 5. I'm just going to subtract the 7 and the 5 here to give me 2. Now what I am going to do is, because I have a number like 5 squared, I actually want to multiply that out and say, well, what is 5 times 5? And that would be 25. Okay, so whether you're doing it with variables or you're doing it with numbers, remember your base is not changing, you're simply subtracting those exponents. If you have a number like 5 squared, you want to go ahead and multiply that out. However, if it came out to be x squared, we would just leave it as x squared. So our next rule is our negative exponent rule, and we actually have two versions of this. That's why I've split this into two places here. Our first rule says that if I have a to the negative n, this is the same thing as 1 over a to the n. Okay, so in other words, if I have something like x to the negative 4, this is the same thing as 1 over x to the 4. And the opposite is true. If I have 1 over a to the negative n, this is the same thing as a to the n. So again, if I had something like 1 over y to the negative 3, this is the same thing as y to the third. Now that's kind of a complicated rule, so what I'm going to tell you, and it's kind of silly but it does happen to work, is anytime you see a negative exponent, he tells you I am in the wrong place. Okay, and there's really only two places that a variable can be. He can either be in the top of the fraction, as he is right here because he's over 1, even though we don't have it written, or he can be in the bottom of the fraction like this, where you have the 1 over the a to the n. So basically a negative exponent is just telling you, I'm in the wrong spot. I need you to fix me. So by fixing him in this particular case, we move him to the denominator, placing him over 1. In this one, again, I have a negative exponent. I'm in the wrong place. So to fix me, I need to be moved up. And again, he's technically over 1 here. We're just not writing that portion of it. Okay, so for our first example here, we have x to the 4th times x to the 0. And there's really two different ways you can look at this problem. Typically the way that I look at it is I'm looking at a multiplication. If you'll remember, our product rule says that if we're multiplying two variables together, we take their exponents and we add them together. Well, what is 4 plus 0? That's still 4, so this would be x to the 4th power, and that would be our answer. Okay, so for our second example, we're still looking at multiplication, our multiplication rule. So we have x to the 6th times x to the negative 3. And this is one of the ones where you need to be very careful about your signs. Since we are multiplying again, we're still taking these two guys and we're adding them. But we are adding 6 to a negative 3, which is the same thing as saying x to the 6th minus 3, because adding a negative is the same thing as subtracting. So 6 minus 3 would give us x to the 3rd power. This would be our answer. Okay, so for our third example, we have negative 2 to the 3rd power times negative 2 to the 0 power. Again, notice we have the same base and we're multiplying together. So we can take our exponents and add them together. So this would give us negative 2 to the 3rd power. But now remember, whenever we're having a problem like this where our base is a real number like negative 2, we actually want to multiply this out. Remember that this is negative 2 times negative 2 times negative 2, so 3 negative 2's multiplied together. These first two are going to give us a positive 4, because a negative times a negative is a positive. We're going to multiply it times one more negative, and that's going to give us negative 8, and our answer would be negative 8. So for our next problem, we're actually looking at our division rule. So we have x squared over x to the negative 6 So since we're dividing these guys, we are going to subtract. Again, this is one of the ones where you want to be very, very careful with your signs because you're actually doing 2 minus a negative 6. Well, if you think about your sign laws, 2 negatives right here make this a positive, so we're actually saying x to the 2 plus 6, and 2 plus 6 would give us x to the 8th. And guys, remember, I'm just showing you one method of doing these particular problems. There's more than one way to do this. It's just whatever you see and feel comfortable with the most. Now, one of the things we really haven't talked about much yet, but it is included on every single one of these instructions, is that we want to have all positive exponents whenever we're doing our final answer. So as you can see, this particular question has x to the negative 7, and the only thing that we really have to talk about is the fact that our exponent is negative. And remember what we talked about in our rule. This says I am in the wrong place. So right now he's technically over 1, so to make him in the right place we need to flip this over. This would be 1 over x to the positive 7. And notice that the entire term moves to the denominator, not just the 7, but the whole thing, x to the 7th. And what we change is the fact that the negative becomes a positive 7.